All right, so as promised, we're back with another cute little language. So we're still going to be living in the math sphere, but we're moving away from elementary school and decimal numbers and into middle school and cool little linear equations. So here, these linear equations are extra cool in that they have three variables, so x, y's, and z's. And the way that we're going to be viewing these equations is essentially all of the variable stuff is going to be on the left-hand side, and all of just the straight number stuff is going to be on the right-hand side, and they're going to be separated by an honest to goodness little equals sign. So just to kind of remind you what that would then look like, we're going to have something like 86x minus 75y plus 309z equals 1337. And that one's an honest to goodness little linear equation, but we don't actually have to have all three variables either. So we could have something like negative 42y plus 42z equals 7331. Before we jump into actually trying to draw this thing out with some regular expressions, I should make it known that when I type these out, I actually have little spaces in them. But when we convert it into a regular expression, I'm going to assume all of our inputs don't have those spaces. So I don't have to deal with white space and all that kind of stuff. So just view these as squished little equations, and then we'll run with them. Cool. All right. So to help us out, I'm going to think about a couple just easy examples that have maybe just one variable that can kind of build up some momentum to try to see these more elaborate ones come into play. So a couple maybe easy examples would be, let's say, x equals negative 1337. So a single term on the left. We could also have something like negative 42x equals, let's say, 10. And that gives us kind of enough of a flavor for what this should look like. So what you can see is reading this thing left to right, we're going to have this optional negative. So that looks like, hey, do you want a negative? Negative question mark. Then what happens is we're going to have some digits, but we might not have any digits at all. So you can see that that x doesn't have a digit in front of it. So what that looks like is I can take any number from 0 to 9, and I can have as many of them as I want, including none of them at all. And then I'm going to have a forced x. And then that's going to equal, well, the thing on the right could be negative, so it's negative question mark. And then it's going to have some numbers. And we need to have at least one number on the right-hand side because it doesn't have the kind of x to help it out at all. So it's going to be some number, any number of them, as long as we have at least one. Basically, I don't want something that looks like x equals. And I for sure don't want something like x equals negative because that doesn't mean anything. So we have some combination of x's equals a for sure number on the right-hand side. So an honest to goodness, nice little just digit. It could be 1337. It could just be the number 7. It can be any combination of digits that I want as long as I have at least one of them. I should make it known that there is technically a little dot at the end of that example right there, which is just because it's the end of that sentence. It's like, that is equations of the form blah. And then I put a dot at the end to kind of represent that it's the end of the sentence, realizing or forgetting to realize that that might look like I'm allowing to have a decimal point in there. But here I'm just viewing this as just straight integers, so no decimals at all. Cool. All right. So that's my initial structure, and that would work out totally fine. That would validate this thing. It would validate that thing. Everything is awesome. What it wouldn't work with, though, is it wouldn't work with things of the form 2x plus 3y equals 10. Or 2x minus 3y equals 10. And it wouldn't work with something that just said 3y equals 10. In all of those scenarios, we have y's coming into play, and this thing below does not handle the additional y. So what I want to do is I want to try to fix this thing. And the way that I'm going to currently fix it works, but it's going to have some awkwardnesses come into play. So once we actually type it up, we'll double back to why it might be somewhat awkward. And then I'll let you kind of snowball it out of control to think about how you might fix it, or if you'd want to fix it, or if you care at all about trying to fix it. So what I'm going to do is I'm still going to keep that first section the same. Still a possible negative, because that one starts with like a negative. Still any number of digits that I may or may not want. But now what's going to happen is that I'm going to choose from x, y, or z as my variable. So again, the bracket means x or y or z, but I have to take one of them. That would then still validate this thing, that thing, and it actually would work with that thing. Well, once I put the equals part of it, but it would work with all of those. What I need to do then is I need to introduce the additional terms that could or could not come into play. So to do that, I'm going to open this up as a big old parenthesis, and there's going to be a star at the end of this, is that this term can toggle on or off as many times as it wants. All of these new terms are going to be started up with some symbol, either a plus or a minus. If you think about 2x, the next thing would be a plus. Here would be 2x followed by a minus. So I'm going to have to choose one of those symbols. So here we're just dealing with linear equations, so I'm not doing multiplication or division or any of that kind of junk. Just grab your favorite basic operation, throw that symbol down, and then move on. What happens next is basically a rinse and repeat of the digit followed by a symbol. So here I'm going to allow for any number of digits. Here I'm allowing no digit because the equation x plus y equals 10 is totally fine. And then I'm again going to choose one of those variables. So x, y, or z. That entire block in purple could be executed if it wants to be, could be executed twice, could be executed 10,000 times, or it could be executed 0 times. So I'm going to throw an asterisk around that thing. Then I'm still going to finish this off like I did before. So it's going to be equal to a possibly negative number on the right. And I need there for sure to be stuff over there. So I'm going to throw this with a plus sign. So we get that thing. Let's flip it over to an implementation mode so I can chat about some of the weird things that could possibly come up. So let's share my screen into that. Move out all of the junk that I have on it. Remember that, hey, we can do decimal numbers, but now I'm going to erase all of that. So let's maybe make our little list of things that should pass. So I had what? X equals negative 1337. We had 42x equals 10. Maybe it was negative 42 technically. We should have things like 2x plus 3y equals 10. We have 2x minus 3y equals 10. We probably should have 2x plus 3y plus 4z equals 10, things like that. Things that would then fail would obviously be like 42x equals, I guess we could also have just like equals negative 9, where I don't have a left-hand side. If I'm completely just missing anything, if I just have an equal sign, that's obviously garbage, and then just numbers like 42 would fail as well. So it's pretty easy to build the failed collection, so we'll go from there. All right, so now we got to type this all out again. So we have negative, possibly. Then we're going to have some digits, and as many digits as I want. So here I'm going to use the \g because it's a little bit easier for me to type out. Then I have to have an x, y, or a z. Then what's going to occur is I'm going to have a section that is going to be allowed to kind of toggle on and off as many times as it wants to be. All of those terms start with a plus or a minus. The plus and the minus are both going to be nice literals. So it's inside of this list. So I have the matching plus and I have the matching minus. Because this is in the bracket, it did not need to be escaped. So then I'm still going to have the digit afterwards, and I can have as many digits as I'd ever want. And then I'm going to have the x, y, and z. That block can then exist as many times as it wants. So I already put the star there. Now it's going to be equal to a possibly negative digit as long as I have at least one of them. So I was mentioning that as I went, so I wanted to get it all typed up, and now I'm going to double back on that. So this plus obviously on the very end is meaningful in that it's going to say that I have to have at least one of them. This plus is actually on the inside of this bracketed structure. So what occurs then is that that is happy in that it's like, hey, what's going to occur is that one of these two things, because it's in this, it's actually totally fine. It doesn't need to be escaped. You could escape it if you want to, if you want to just be extra crystal clear on it, but it actually doesn't need to be escaped because it's in that bracket. So just a thing to keep in mind is that when you have some of these literals in there, it's okay. But if you wanted to escape it, you still could. Cool. It's also nice because you hover over it. It's like, hey, it matches the plus character. Whereas over here, it's saying matches one or more. So you kind of can know, is it talking about the literal plus or is it talking about this extra little quantifier plus? Sweet. All right, so that does pass with what it's supposed to, and it fails when it's supposed to as well. But now I want to dwell on a couple weird things that it is actually going to pass on. And you might have already realized it while we were typing these things up. Officially, this doesn't care about seeing the same symbol twice. So I could have x plus x equals 10. You could also have x plus x plus x plus x plus x plus x plus x equals 10. It doesn't care how many versions of those, which is totally fine. You just might end up getting weird things like 4x minus 4x equals 10, which the left-hand side would simplify down to a 0, which is weird when it says 0 equals 10. So officially, you're going to get something that's definitely false, but it's still an equation. It's just a false equation. So there's a couple weird things that do occur if you type it up like we did here, where we have kind of the X, Y, or Z choose from list, and then another X, Y, or Z choose from list happening over here, in that it's not paying attention to things that have actually been used before. So it's saying X was used here. Well, I can totally use X as many times as I want. Same thing with the Z. The Z happened right off the bat. The Z could happen later. It also doesn't care about the ordering on them. So if I went like 3y plus 2x equals 10, it's totally fine with that as well. So it's kind of a cute example that leans on some things that we know and love as looking at these little linear equations. There's a couple extra new symbols that we were able to bring in. So this nice OR collection of things like X, Y, and Z. Officially, because those are actually in order, I could have written this as X through Z. If I wanted to allow variables all the way from A to Z, you could just go A to Z. But here we are dealing with X, Y, and Z, so I can just type them all out. But you could put a little dash between them as well. It doesn't save any symbols when you looked at that, but if you wanted to allow, W through Z, you might be like W, X, Y, and Z. You might be like, okay, here I'm going to write W through Z, and then be happy. That'll come more into play when we start talking about, words and things like that that are going to honestly work with A through Z, but kind of slowly working our way towards that. So right now, X, Y, and Z, we had some digits, we had some possible negatives, we have this block that can occur over and over and over again. We have the plus sign at the end, which was meaning we had to have at least one digit on the back end, whereas over here we had a plus that was representing the honest to goodness plus in the equation. So those are different pluses. So here's that one, here's this one. If you wanted to escape it, you could, just to make sure that you're not, losing out on it or anything like that. We'll go from there. You can see that it talked about the same thing then. Neat. All right, so we're going to pause it here and then rinse and repeat this a couple more times.